In this video, we will apply the sum identities from trigonometry to help answer a question about adding two angles. So suppose that I have two angles. The first angle, theta, we learn is in the second quadrant, and we know that the sine of that angle is 3/5. And our second angle, phi, we learn is in the first quadrant, and that the cosine of that angle, cosine of phi, is equal to 1/2. Our task is to draw a unit circle that shows both of these angles, and then determine the coordinates of the point corresponding to the angle theta plus phi. Let's start by drawing our unit circle. Here's my circle. It's a unit circle because its radius is 1. Radius is 1. And our angles, we're told some information about them. And so the first angle, theta, we know it's sine. And the sine corresponds to a y-coordinate. So our y-coordinate is 3/5. So if I look at my y-axis, I need to choose something that's 3/5. So this is 1. Let's figure out where 3/5 would be. 1, 2, 3, 4 fifths. There we go. So 3/5 is about this high. To say that the y-coordinate is 3/5 means we're looking at a height of 3/5. And so there are actually two angles, 2 points on the unit circle that correspond to a sine of 3/5. This is why we need to know which quadrant it's in. One point happens to be in the first quadrant, and my second point happens to be in the second quadrant. So we're going to choose the one in the second quadrant. Okay, now we know our first angle is theta, and we know that the y value is 3/5. Our second point is in the first quadrant, and we know that the cosine of that angle is 1/2. So the cosine corresponds to an x-coordinate, and so our x-coordinate is 1/2. And so we're looking at a point that has x equals 1/2. Again, the circle intersects this line at 2 points. But only one of these is in the first quadrant, so we choose the one in the first quadrant, and our second angle, phi, corresponds to this point with an x-coordinate of 1/2. Let's summarize what we know. For our angle theta, we know the y-coordinate. So we don't know the x-coordinate yet, but the y-coordinate is 3/5. And for our second point, the angle phi, we know the x-coordinate is 1/2, but we don't know the y-coordinate. In order to use the sum identity for sine and cosine, we're going to need to find those other values. In both cases, we'll use the trigonometric identity called the Pythagorean identity, coming from the unit circle, x squared plus y squared equals 1. In the language of our trigonometric functions, this is the cosine of an angle squared plus the sine of an angle squared is always equal to 1. And I can use that to solve for the unknown value. Let's do our angle phi first. We know that the sine of my angle theta equals 3/5. That's a y value. And so when I put that into my x squared plus y squared equals 1 formula, x I don't know, y is 3/5, so that's going to be squared will be 9/25 equals 1. And so x squared, when I subtract 1 minus 9/25, I get 16/25, so that x equals plus or minus 4/5. Now remember, we had 2 points on the line where y equals 3/5, and the plus minus captures that idea. We're in quadrant 2. And so that tells me my x value is actually negative 4/5. So let's add that to our information that we know. Negative 4/5 is my x-coordinate. For my second point, I know that the cosine of my angle phi is equal to 1/2. That is an x-coordinate, And so x squared plus y squared equals 1 becomes x squared will be a fourth. The y I don't know equals 1. So y squared equals 3/4. Y equals plus or minus square root of 3 over square root of 4, that's 2. And again, I need to think about which quadrant I'm in. I'm in quadrant 1. And so my y values in quadrant 1 are positive. So I know my y value is positive square root 3/2. And so I can add that to my information. All right, so I'm going to clean up a little bit here. And we're going to summarize what we know. For our angle theta, we know that the cosine of my angle theta equals -4/5. That was the x-coordinate. And the sine of my angle theta was equal to 3/5. For my second point, I know that the cosine of phi equals 1/2. That was my x-coordinate. And the sine of my angle phi was equal to the square root 3/2. All right, from those, I'm now going to use the sum identity for sine and cosine. So the sum identity for sine says that the sine of a sum, theta plus phi, will be sine theta cosine phi plus cosine theta sine phi. So as I use the values, my sine of theta was the value of 3/5. And I'll multiply that by the cosine of phi, which was a value of 1/2. And I'm going to add the cosine of theta, which is -4/5, and I'll multiply that by the sine of my phi, which is square root of 3/2, to give me a final value of 3/10 minus 4 square root 3/10. So I get 3 minus 4 times the square root of 3 all over 10. I'll get the cosine in a similar way, except that the cosine ends up mixing cosines and sines together. So I get cosine theta cosine phi minus sine theta sine phi. So the cosine of theta was -4/5, and the cosine of phi was 1/2. And the sine, let me multiply, and I subtract the sine of theta was 3/5, and the sine of phi was square root 3 over 2. So that when I simplify this, I get a cosine of the sum is -4 minus 3 square roots of 3 all over 10. All right, so now I have my coordinates. The angle theta plus phi, if I add these two angles, I'm going to end up, let's see, I need to figure out which quadrant I'm going to end in. If I use a calculator, I can get decimal values here. So my sine is approximately -0.393, and my cosine is approximately -0.920. Notice that both of my coordinates are negative numbers. I am almost all the way to the left and about -0.4, so that's about 2/5 down, and so my sum is about -0.4 and like -0.92. This is approximately the angle of theta plus phi.